Welcome, dear listener, to another deep dive. Today, we're mining the online encyclopedia of integer sequences, the OEIS. It's just such an indispensable resource, isn't it? Especially if you're fascinated by numbers.
Oh, absolutely. And as part of our series for, number theory students, we're focusing today on a sequence that I think beautifully shows both elegance and complexity.
Okay.
It's the generalized tangent numbers, A000320 in the OEIS.
Generalized tangent numbers, D5, N. Okay.
Exactly. And what's intriguing right off the bat is the name itself. It hints quite strongly at trigonometry, tangent numbers, but there's this specific parameter, the 5, that makes it really captivating.
Okay, let's explore that. Our mission, as always, is to sort of unpack what makes these numbers compelling, look at where they came from, and how they fit into the bigger mathematical picture. You've given us some great sources, so let's just jump right in.
Sounds good.
So A000320, these generalized tangent numbers, D5, and for someone who hasn't maybe seen them before, what do they actually, look like?
Well, they grow quite strikingly. The sequence starts with 4, then 272, then 55,744.
Okay.
And the fourth term is already, 23,750,912.
Wow. Okay, so it jumps up really fast.
Extremely fast. You can see the rapid expansion almost immediately.
And looking beyond just the numbers, there's some structural details in the OEIS entry, like the offset set is 11.1.
Yes, that's right.
Which means the first term corresponds to N1. That's quite important for students, isn't it? It tells you where to start your index.
Absolutely crucial. It avoids any misinterpretation when you're, say, applying a formula or coding it.
Right.
And it's also interesting to note the old identifiers, M3722 and N5521.
Ah, yeah. What's the story there?
Well, they're sort of historical markers. They show how these things were cataloged before the OEIS, founded by N.J. Sloan, became the standard. It speaks to the evolution of mathematical databases.
And Sloan himself authored this sequence entry.
He did, yes. It's featured in his foundational works like the Handbook of Integer Sequences from '73 and the Encyclopedia with Simon Plouffe in '95.
So it has a solid pedigree. Links back to, I see here, D. Shanks' work in the late 60s.
That's correct. Research on generalized Euler and class numbers. So, yeah, this sequence has deep roots. It's not just some recent curiosity.
Okay, so let's get to the heart of it, the definition. How is A000320 actually defined?
Yeah.
Is there an explicit formula?
There is, and it's quite elegant. Peter Lishney provided one back in 2021. Essentially, you look at the power series expansion of a specific function.
Okay.
The function involves sec5x multiplied by sen x plus sin 3x.
Trig functions again?
Exactly. And the term an in our sequence is basically the coefficient of x to the power of 2 and 1 in that series expansion.
Right.
Multiplied by 2 and 1 factorial. So it's this really nice connection between calculus, series expansions, and these discrete numbers.
That is incredibly precise. It really shows how these numbers, which seem maybe abstract at first, pop out of calculus. Can you maybe elaborate just a bit on how that sec5x and the sin plus sin 3x part, how that generalizes the classic tangent numbers? What does that 5 frittily do?
That's a great question. The 5 foot in the sec5x acts as a key parameter. Standard tangent numbers might come from simpler functions like just secs or tan x.
Okay.
Introducing the 5x and that specific combination of sign terms, it creates a much richer, more complex generating function. The coefficients that fall out of this specific function form our sequence, A000320. It shows how changing the function slightly can lead to entirely different, though related, sequences of numbers.
Fascinating. And the sources even give Maple and Mathematica code, which I guess confirms you can actually compute these things.
Oh, absolutely. Computability is key.
Yeah.
Especially for exploring patterns in longer terms. These tools are invaluable for that kind of investigation.
Which brings up the question, why do these generalized tangent numbers really matter? I mean, beyond the nice formula, what about their connections?
Well, that's where the OEIS cross-references come in handy. You mentioned A000318, A000187. These aren't just random links. They often signal deeper structural relationships. Maybe these sequences count similar combinatorial objects, or they share properties related to their generating functions. It means A000320 isn't isolated. It's part of this dense web.
Like a node in a network connecting different ideas.
Precisely. It helps build a more complete picture of how different mathematical structures are, intertwined.
And the keyword that just means non-negative, right?
Yes, non-negative integers.
That seems like a useful tag for students. It simplifies things No need to worry about negative or complex values here.
Exactly. Knowing that upfront can streamline your analysis quite a bit. You know you're dealing purely with positive integers or zero.
Okay, so wrapping this up for, for you, the number theory student listening, what we've looked at with A000030 isn't just a sequence. It's really a case study.
I'd agree.
We've seen its values, its history tracing back to Sloan and Shanks, and this elegant generating function that defines it. It shows how these mathematical objects are all connected.
And that's the crucial takeaway, I think. Sequences like A000320 aren't just curiosities. They're threads in this huge mathematical tapestry. Understanding how they're derived, how they connect, that's key to seeing the bigger patterns in number theory. I remember when I first encountered these kinds of connections, it felt like learning a secret language.
That's a great way to put it. And it leaves us with maybe a final thought for you to ponder. Given this intricate formula, these connections, what other generalizations might exist? What surprising applications could these generalized tangent numbers have down the line?
There's always more to uncover. Often the most interesting discoveries come from exploring these specific, well-defined objects.
Absolutely. We definitely encourage you to dig into the OEIS yourself. Until next time, keep diving deep.